My name is Mian Sadegzadeh. I'm a product marketing engineer in Emerging Connectivity Solutions Group. Today I will be talking about how to add Bluetooth to your microcontroller-based systems. And these are systems that include TI controllers like MSP430 and Stellaris. If you're not aware, TI has been in the wireless market for over 10 years. In that time, we've produced multiple generations of wireless technologies like Bluetooth and Wi-Fi, over 7 generations. We've shipped more than 1 billion units in that time. TI has a lot of history in the mobile handset, cell phone market. Through this, as you can imagine, low power is an extremely important criteria. So we've designed our Bluetooth devices to be extremely low power. We've also tested and integrated our Bluetooth devices with TI controllers like MSP430 and Stellaris to make your overall system integration much easier. And we provide flexible engagement and support models to give you, the right things that you need. This is an overall look at TI's connectivity portfolio. You can see in red all of the wireless technologies that TI has. TI has the broadest wireless portfolio in the industry with over 14 wireless technologies that you can see here, like RFID, NFC, PurePath, wireless audio, Zigbee, ANT, Bluetooth, Wi-Fi, GPS, a wide variety. Today we're going to focus specifically on Bluetooth. I'll also touch on ANT technology as well. And the devices that we'll be focusing on are the CC2560 and 67. And just keep aware that the WL1271 is also a Bluetooth capable device. Let's put Bluetooth in perspective of some of the other wireless technologies. From a range perspective, Bluetooth, you'll find, can go about 10 to 30 meters, depending on the application and the environment. ANT technology, Bluetooth Low Energy, go about 10 meters. 10 meters in a real-world application would be about a room's range of length. You can see that compared to Wi-Fi or Zigbee, which can go about 100 meters, which would be a house range, for example. And then sub-1 gigahertz technologies can go much further. These will vary, of course, if you have a power amplifier. You can increase your range significantly. From a throughput perspective, Bluetooth comes in around 2 megabits per second. This is the highest data rate for these very low power technologies. BLE, ANT, R4C, Zigbee, you'll see those around 50 to 100 kilobits per second throughput. Wi-Fi, on the other hand, will be upwards of 20 megabits per second. From a power standpoint, as you can imagine, since Wi-Fi is the highest throughput, it will require the highest power. A misconception, though, is that Wi-Fi requires line-powered, but however, it can be battery-powered, in this case by lithium-ion. Bluetooth, however, can be powered by a AAA battery source, and then your BLE, ANT, and proprietary technologies will be possible to use a coin cell, so very low power there. Bluetooth in general can be used for any type of wireless data, audio, or voice. As we mentioned before, the range you're looking at is about 10 to 100 meters, depending on the environment, the application, or if you have a power amplifier attached as well. We call this range a personal area network, and you can see with this man here, the idea that he has devices connected in his own little bubble or his personal network. The Bluetooth connections are very fast. They're also secure, and so as Bluetooth is pairing is when it invokes the security measures. For example, you've probably seen on your cell phone when you want to connect to another device, you need to enter the PIN or the passcode in order to do that. Also, the power consumption is fairly low. You can power the device off of a AAA battery. The data rates, as we mentioned, are about 2 megabits per second, which is quite high considering the low power. Bluetooth sits in the 2.4 gigahertz ISM band, and this allows you to deploy the device anywhere. It uses a frequency hopping mechanism, which I'll discuss in a moment. Also, the device forms piconets. This is the network topology. So a piconet is made up of one master and up to 7 slaves, and the devices can switch roles, and they communicate with each other in a round-robin fashion in those piconets. The Bluetooth Special Interest Group has defined a set of profiles, and these profiles are going to make sure that Bluetooth A is interoperable with Bluetooth B, no matter what supplier or vendor they come from. and Bluetooth is largely deployed. There's over 3 billion devices in the market today. So let's take a look quickly at how Bluetooth works. I mentioned that it sits in the 2.4 GHz ISM band. ISM stands for Industrial, Scientific, and Medical. This band can be quite crowded, and because of that, it's noisy. The reason why is because this is where your microwave ovens, your baby monitors, even Wi-Fi, Zigbee devices, cordless phones, this is where they reside, is in this band. Because of that, there's a lot of traffic. Now what Bluetooth does to avoid interference with that traffic is a technique called frequency hopping spread spectrum. So in the Bluetooth band, there are 79 channels, each of 1 megahertz each. So what Bluetooth will do is hop in between these frequencies in a pseudo-random pattern that's known at both the transmitter and the receiver end. So if it senses that another device is on that channel, it will jump around it, and this allows it to avoid any interference. Something to keep in mind are the certification classes that are required of Bluetooth devices. A Class 2 device is one that is certified at 4 dBm output power. And then I show you what kind of range you can get with a Class 2 device. This would be about a room's range. Now a Class 1 device is certified at 20 dBm, so a much higher transmitter power. With this transmitter power, you can get up to a house range. Now keep in mind that in order to get such a range, you'll need an external power amplifier on that device to get up to 20 dBm. There's another class that is a non-standard naming convention called Class 1.5, and this is what we denote the TI device as. This means that you can achieve increased range without using an external power amplifier. So with TI devices, you'll find them to be around 9 or 10 dBm, so much higher than a Class 2 device. This device would then need to be certified as a Class 1 device. You can see some of the applications that Bluetooth is well suited for, from sports and fitness to health. TI has a new design with Fossil called the MetaWatch, and that's using TI's Bluetooth technology. You've probably also seen Bluetooth-powered mouses in your office. Also on the entertainment side, we have a demo that shows Stellaris microcontroller being used with our Bluetooth device to stream audio from a cell phone to the development kit. I mentioned before that profiles are defined by the Bluetooth Special Interest Group. This allows devices to be interoperable, so no matter what vendor they're coming from, the two devices will work together. The profiles are based off of applications and use cases. So here, for example, I show the application of hands-free profile. Many of you might have this in your car. So on the left, I show that both the car and the cell phone support hands-free profile. Then they are able to connect to each other. On the right-hand side, however, the car has hands-free profile, but the cell phone does not. These two devices will no longer be able to communicate with each other because they do not support the same profile. The profile defines how the devices will connect and communicate with one another. Let's take a look at the types of profiles that Bluetooth has. Serial port profile is the one that you will see on TI platforms. This is a good general data pipe to replace a serial cable connection, and we'll see this more again. Also, object push profile is a way to transfer, for example, a business card from one cell phone to another. You can also do a file transfer from one device to another. You're probably all very familiar with headset profile. A couple other profiles that are significant are A2DP, Advanced Audio Distribution Profile. This is how you send an audio file from, let's say, a cell phone to speakers. And HID is Human Interface Device Profile. This is what mouses, keyboards use to connect to a computer. The TI device that we are offering that provides Bluetooth is called the CC2560. We've taken this device and worked with Panasonic to integrate it into a module. The module is going to offer many benefits, which I'll show in a moment. But this device then includes the filter, the antenna, the fast clock. There's another device that's also available without the antenna if that's something you prefer. A couple key things to note about this device is the RF performance, plus 10 dBm transmit power and minus 93 dBm receiver sensitivity. This is the best-in-class RF performance that you'll find. What does this mean for your end application? This means that you can have increased range, more than what you would have with a non-TI device. Also the quality, because the device can adjust based on range to make sure that you're getting the highest performance possible. Another thing to denote is the power. TI's device has the best-in-class power consumption by using a technique called low power scan. Through this we get a consumption of 145 microamps. What this means is that in traditional Bluetooth devices, they're usually in some sort of scan mode where they're looking for other Bluetooth devices to connect to. When doing this, you have to open up a reception window on each of those 79 channels. This consumes full active power. You have to do one channel at a time. It can be time consuming, but also very power hungry. TI's technique, however, opens up an energy scan across all the channels simultaneously, searching to see if there's any activity on these channels. And this will lower this will give you a third of the power consumption that you would using the traditional method. I mentioned modules and that there are many benefits of modules versus doing a discrete or an onboard design. A couple things to point out is that to do an RF design, as many of you might be aware, requires quite a bit of expertise in order to do the signal routing, the layout, especially the shielding. So this is something that our module manufacturers, it's their core competency and they've enabled for you. Another thing is from a procurement or assembly or manufacturing standpoint, rather than having many components to put together yourself, now you just have one device. This is going to reduce your production costs, also your operation costs. So something to keep in mind. Let's look at the CC2560 module as a system at whole. So on the left side you'll see MCU, which means microcontroller. I mentioned TI microcontrollers like MSP430 and Stellaris. So on those devices is where you will develop your applications for your specific product. This is also where the Bluetooth stack and the profiles will reside. It will then connect to the module via a UART, and here is where you'll see the Bluetooth processor along with the MAC, baseband, and the radio. The red is the TI Bluetooth chip, and then in the dark gray is the Panasonic implementation. The development tool that we provide that allows you to evaluate with a microcontroller and our module is the MSP430 and CC2560 platform. So you can see in the middle the MSP430 experimenter board. What we've done is attached our module on a connector board, you can see there in blue, to the MSP430 experimenter board. The module itself is shown there, that small square in white. So this will allow you to develop with various applications to see the code that is used that you can then apply to your own device. The software that's included with this platform, with this development kit, is the software development kit. This is available for the specific MSP430 called MSP430 BT5190. This device includes the Bluetooth stack, royalty-free. The stack is provided by MindTree. It's called the EtherMind stack. And again, this is provided royalty-free when using the BT5190. This will allow you access to the APIs, and the sample applications will show you how to use these APIs. The size of the code, just to give you an idea. So on the left side, you'll see the mandatory code that's required. For the EtherMind Bluetooth stack, the code is about 60K. There's some device-specific code, which is about 6K, and some miscellaneous files. So total about 77K that's required to run on your host like MSP430 or Stellaris. The BT5190, however, is a 256 KB flash device. So when you take away the mandatory code that's required, you still have about 180K left for your own application development. The demo and sample applications that we provide give you a great idea, one, of the Bluetooth process, and two, of the APIs that are used. One of them you can see on the left is a video game where you can use your Bluetooth and MSP430 controller to send accelerometer data, like a video controller, video game controller to another Bluetooth and MSP430 device. And this will then display your movements onto the screen to control here a penguin that's moving through a race course. It's a really fun demo to do. Another one is a temperature demo, and this shows you the temperature of one Bluetooth device and then the temperature of another one. And through this process, it shows you, the steps that Bluetooth requires, which I'll show you in a moment. And the last one is an RF link demo, where it gives you the RSSI of the device and also the transmit power. So you can see, as you move in range, how those numbers change and their effects. The Bluetooth process that you'll see in these applications, plus the same ones that you'll do in your own development, is first you'll want to initialize the Bluetooth stack. Then you'll want to turn Bluetooth on. When you do this, you can make your Bluetooth device visible. So that means that other devices can see your device and therefore connect to it. This is also when you'll set up the low power scan that I talked about earlier. Next, you can do an inquiry to see if there are other devices that you want to connect to. And this is when you set up the frequency hopping scheme. The next step then would be to connect if you find a device you want to connect to. And this is when the security mechanisms are invoked, and you can store those for the next time. After this, you can now send data. So to transmit or receive, in our case we use SPP profile, serial port profile. And also you can tell the device to go into an idle or to a sniff mode. So you can maintain a connection while in idle mode, but decide not to send data during that time. Or you can tell the device to wake up at a certain interval and send the data at that time. These are techniques you can do to save on power. Keep in mind that you don't have to do the visible or the inquiry steps if you already know the device that you want to connect to. Now I'll show you the APIs that are used in these processes. So the first, we group them into three categories. The first is GAP, Generic Access Profile. So this is going to control some of the stack basic operations. For example, you can see Bluetooth HCI, change local name, and this is how you would configure the name of the Bluetooth device. Another set of APIs is called SDP, Service Discovery Profile, and this is going to configure the stack and the SPP profile. Lastly is the SPP, Serial Port Profile APIs, and this is what you'll use to actually send and receive data. For example, Bluetooth SPP Connect and then Bluetooth SPP Send. So you can see the APIs are fairly simple. There's not very many of them, and these are what you'll use in your own application. So let's take a look at it in a real-world application. So I show the processes that you go through there in the light blue color. On the left are the APIs that are used. So first, like we talked about, we'll initialize our Bluetooth stack, and then we'll turn Bluetooth on. Next, we'll do an inquiry to see if there are other devices to connect to and get the name of those devices. Then we can create a connection to those devices that we found. After that, we'll set up our SPP profile and then connect. After that, we can now send data via SPP. And then, if we would like, we can disconnect and stop the SPP. So these are simple steps, simple APIs that are used in the application, which you will reuse in your own application. I also want to show you a preview of the Stellaris and Bluetooth platform. This is being released in July. So this is similar to what I showed you with MSP430 and Bluetooth. However, this is now using the Stellaris Cortex M3 device. So if you need higher performance controller, you need more integration, then Stellaris would be the right fit for you. So here we also provide sample application demos and code. And this one we do an A2DP demo. So that allows you to send and stream audio from a cell phone to the development kit, from any type of phone. I'll touch briefly on ANT technology. I mentioned it towards the beginning as another technology that TI supports. I want to make you aware of it because it's an ultra-low power technology that if you need to enable sensors, this is a great technology to consider. So you can consider this as a type of Bluetooth technology, but that's enabled for very, very low power. The power that's required, in this case, you can get by with a coin cell, and you can have this coin cell operate, for 1 year or longer. What this is going to do is enable wireless sensors. Wireless sensors are obviously very small, so by having a coin cell, it's much more suited than having AAA battery, for example. We're seeing a lot of traction in this market with sports and fitness applications and also medical and healthcare devices. As you can imagine, there's many opportunity for wireless sensors there. ANT is created by a company called Dynastream, and it also operates in the 2.4 gigahertz ISM band. Like with Bluetooth, ANT defines its own stack and set of profiles. Here on the left side and the right side, you can see some example types of profiles. So for example, heart rate or speed or cadence. You can see some of the applications here from a sports perspective, also a health perspective, and even home monitoring as well. So these devices will then send their data to some kind of collector device. So that might be a laptop or a cell phone or a set-top box or a TV. Now, there's something to consider here. These devices in the middle that I just mentioned currently, for the most part, only support Bluetooth. They don't support ANT. So how would they connect to an ANT sensor, for example? So TI has come up with a solution for that. And this is to serve, as a option until cell phones, laptops start to incorporate ANT technology. Currently, as I mentioned, they support Bluetooth technology. So here you would take your ANT sensor, as you saw in those previous applications. Then you would send it to a device that can speak both ANT and Bluetooth, and we call this an aggregator. Then it can now speak to those devices, the end devices that you want to send the data to, like a cell phone or a laptop or a tablet. The device that does that is called the CC2560. We worked with Panasonic again to integrate this into a module called the PAN1325. This is the first device in the market that includes both Bluetooth and ANT on a single chip. The system of an ANT and Bluetooth device will look very similar to what we saw before, but now on the microcontroller, like the MSP430, will have not only the Bluetooth stack and profiles, but the ANT stack and profiles. And on the radio itself, there's two processors, Bluetooth and ANT, and this allows the devices to coexist, or the technologies to coexist together. The development platform that's available also uses the MSP430 experimenter board, and then we've attached the module to a plug-in card that attaches to the experimenter board. You can get an example of the data process here, and this is the kit that we provide. So there on the top left in green is a device that's simulating heart rate sensor data. So this is sending that data via ANT to the Bluetooth plus ANT device that's shown there highlighted in red. So that's communicating via ANT. Now the device will communicate via Bluetooth to the laptop. We provide a USB stick with Bluetooth capability in case your laptop does not have Bluetooth. And this is sending the heart rate monitor data, again from the simulator to the Bluetooth plus ANT device and back to the laptop. To get a perspective of the code size, again you'll have your Ethermine Bluetooth stack from MindTree, royalty-free, which is about 60K. The difference here, however, is that the init script for the 2567 is much larger. This is where the ANT stack and profiles are contained. So this is about another 60K. So here, you'd still be using the BT5190 from MSP430. That has 256K flash. The mandatory code is 133, so that leaves you 123 kilobytes for your own application development. There are several avenues that you can use to get started. One is to get started using the platform. Again, the platform is taking our host controller like MSP430 or Stellaris and connecting that with our Bluetooth or our Bluetooth and ANT radio. What we do with that is provide you all the software that you need, for example, to connect the drivers together, the application code that you can use to start your own design. And this is greatly going to speed up your own development. We have documentation and getting started guides all available on a wiki to give you everything you need to begin. The devices that are available are CC2560-PAN1325 for Bluetooth, or CC2567-PAN1327 for Bluetooth plus ANT. If you're not aware, we have a great forum available, and this is where you can submit your questions to engineers for quick support. The link for that is ti.com/yconforum. Also, the Connectivity Wiki is where you'll find the step-by-step guide of how to set up your applications, how to set up the device, all of the software downloads that you'll need. And also, we work with several partners. If you need customized support or additional profiles supported, you can work with these partners. So again, please see the Connectivity Wiki or the forum to get started with questions. The Bluetooth device, again, you can see the part number here. The development kit is called the PAN1315 Bluetooth Evaluation Module Kit for MSP430. For Bluetooth and ANT, you can see the part number here, and the kit that we reviewed is called the ANT plus Bluetooth Health and Fitness Aggregator Kit. A device that we didn't go into today is called the WL1271-TWE. This is a device that incorporates both Bluetooth and Wi-Fi, so if you have a need for Wi-Fi, this would be a device to consider. And these we enable on microprocessors like our ARM Cortex-A8 or ARM9 devices. Thank you very much for attending this session, and we hope to help you with Bluetooth as you get started. Thank you.